Morning, fools. So hopefully this helps you out for your exam tomorrow. So a little prepared. We're going to go through it. So given that ABCD, ABC is the dilation, how the angles and side lengths of the preimage related to the angles and side lengths of the image. Angles are congruent and the side lengths are congruent. Close. Angles are congruent and the side lengths are proportional. Proportional. Dat. The side lengths are going to be either bigger or smaller, which is what makes them proportional, and the angles will always be congruent, which is what makes it retain the same shape. Scale factor of the dilation shown. So we have 4/6, also known as 2/3. You can check the other ones as well. 10/15 is 2/3, and 8/12 would be 4/6, which is 2/3. So, 2/3. What are the coordinates of r prime? Dilation 0.5 about p. So you're going to make everything smaller about p. So this side is originally 2.5. So now it will be 2.5. 2.5 right there. This top side is originally 4, so it'll be 2, and that goes there. Here's your new little guy, new little rectangle. The coordinates are -1.5, -0.5, -1, -0.5. Graph the dilation of 1/3 QRTW. So if it doesn't give you a point, if there's no point here, then that is just the origin. So you just dilate about the origin. And to do so, you count from the origin, and then you just shrink everything by 1/3. So this is originally up 3 over 2. So it'll be up 1 over 2/3. Up 1 over 2/3, and that is Q prime. Q prime, and just repeat the process for everything. Up 1 over 3 for R, so up 1/3 over 1. Up 1/3 over 1, that is R prime. W is up 4 over 2. So it'll be up 4/3 over 2/3, right there. And T is over 2 down 1, so it'll be over 2/3 down 1/3. That is T prime, and you got yourself a little version of the big shape. Kind of cool. That'd work. It's not going to be exact because you're splitting it up into thirds, but just draw it to the best of your ability. Same thing on the test. What best describes the composition of transformations of maps JKLM? So this one onto this one. So we're going from bigger to smaller. So it can't be that. Can't be that because the dilation has to be a scale factor smaller than 1. So what are we doing? It can't be a reflection over n because then that would put it, that would just put it right here, and then it would, shrink to the origin because there's nothing here. There's nothing here, so the dilation point is just the origin. Dilation point is just the origin. So then, it has to be this. It has to be B. Because then, if you draw, so the reason why I saw that is because if you draw to the origin, all these points are going to line up. Like so. And then that little their little rectangle is going to map onto the bigger rectangle. Kind of cool. Okay, what are the coordinates of V prime after the transformation dilation 5 and translate 3, -2. So we're just looking at V. Just looking at V. And if we do the so we start here first, dilation first. If it's up 2 over 1, it will now be, so V prime after the dilation will be up 10 over 5. And then after the translation, V double prime, add 3, so 13, subtract 2, 3. So, oh, parentheses are already there. 13, 3. Done. Label each statement as true or false. Similarity transformation exists that maps circle P to circle Q. True. All circles are similar, so there's always going to be a similarity transformation. If a similarity transformation maps circle A to circle Q, then it must include a rotation. False. It could be a translation. All circles are similar. True. Talked about that already. Given PQR and STU, what is the measure of angle Q? Angle Q. So the largest side is opposite 70. So the largest side here would also be opposite 70. Then you just do 180 minus 70 minus 46. Grab my calculator here. 180 minus 70 minus 46. 64. 64. Given FGH is similar to LMN, which must be true. So two triangles, FGH, and another similar triangle, LMN, which must be true. FG over LM is equal to FH over LN. Yep. FH is similar to LN. FH is similar to LN. Totally. Measure of angle F over the measure of angle L is equal to G over M. F over L. F over L. It'd be the same angle, so it would just be 1. Yeah. GH. GH is congruent? No, because it's similar, it's not congruent. And H is congruent to M? Yes. Or N. H and N. So now I wrote down the things we need to solve these ones below these next two. Let's do these two first. Which condition would prove JKL? JKL is similar to XYZ. JK over XY, so opposite JK over XY is equal to 1/8. So the big one over the little one would be equal to the scale factor, because 56 JKL 50. So we're going from here to here. 56 over 7, that'd be equal to 8, so no. JL, no, because that's going from big to small. It's equal to 1/8. Or no. Yeah, you can, because you're going from big to small, so you want the scale factor. No, you would want the big number to be on top because it has to line up. Because then that would be opposite. So no. KL over YZ. KL over YZ is equal to 8. Totally. Given AB, ACB, ACD. My dogs are awake. Hi, go. Giving ACD, And ABE, what is AB? ACD, ABE, ACD, and ABE is the little one. We would know that entire length of this is 15. This would be 15 minus 9, which would be 6. And then we don't know what this is. We know that this is 12 plus x. Okay. So we could solve it that way, or we could say that this is 6. That 6 over x is equal to 9 over 12. Yeah, that'd be easier. Let's do it that way. 9 over 12. 6 times 12. 72. Equal 9x. And 8 is equal to x, which would be AB. JL. What is JL? What is JL? So the entire length, so we have to find out what this is. So then we know that all these triangles are similar. So we have a long leg. So I'm looking at this is J, this is M, this is K, and then we have the other triangle standing up, where this would be K, this would be L, this would be M, this is 6, this is 8, this is X, and this is 6. So we could say that 8 over 6 is equal to 6 over x. 36 is equal to 8x. Would that be roughly 4.5? Yeah, 4.5. A. What is AC? What is AC? We know that AD over CD. Let's not use that one. We know some stuff. I want to find this. So we have a leg, a hypotenuse. So what if we did the big triangle, which would be ACB. Now this is X, this is 9. Then we did the little triangle, which is DAC. This is 4. This is X. We can say that x over 4 is equal to 9 over x. X squared is equal to 36, and x is equal to 6. Done. Which triangles are similar to DEF? DEF. DEF. A couple, I'm sure. DFG. DFG. Yep. EGF. Yep. FEG. Yep. And GDF. Yep. G, D, F. Yeah. All of them. What is the value of x? So we have x minus 6 over 3 is equal to x over 5. 5x minus 30 is equal to 3x. 2x is equal to 30. And x is equal to 15. Which conclusion does the diagram support? uv over vw is equal to zy over yx. Totally. Vy. Nope. Nope. And nope. So they're just trying to confuse you with information we learned last topic with that. What is BD? So we have 12 over 27 is equal to x over x plus 5. 12x plus 60 is equal to 27x. And 60 is equal to 15x. 4 is equal to x? Yeah, totally. 4 is x, but that is not BD. BD is the entire length, so 4 plus 9 would be 13. Hey, last one. Use diagram solve for x. 24 over 21 equals x over 7. Whatever 24 times 7 is. 24 times 7, 168 equals 21x. Divide by 21, 8 is equal to x. Done. There you go. Hope that makes you feel better. Peace.